So section 9.3 is all about the quadratic formula, and this is a formula when things can't necessarily be factored. It's like a tool of last resort. If you can't factor it, if you can't complete the square, no matter what, you can always use the quadratic formula. So we have essentially ways to find zeros of quadratic equations. Okay, and well, one, we could factor. If we can't factor, we could try to complete the square. And if we can't complete the square, right, we can use the quadratic formula. And so we're going to come up with how they came up with the quadratic formula right now in our notes. So essentially they took the standard form of a quadratic formula, ax squared plus bx plus c, and they set it equal to 0. And then they started to apply. I mean the math gods, all the folks that came before us to figure out all this stuff that's been passed down for hundreds of years. So here we go. If I do some algebra and subtract c from both sides of the equation, I'm going to get ax squared plus bx is equal to a negative c. And then I'm going to multiply both sides by 4a to make the coefficient of x squared a perfect square. So when I do that, because if we're talking about perfect squares, there's like 4, 9, 16, 25, 36, and so on. 4 is like the first one. So they figured, well, let's multiply this thing, and which was like the extra step we did when we completed the square, by 4a, so that this becomes 4a squared plus x squared plus 4abx. And all that's going to be equal to negative c times 4a, so negative 4ac. And then, right, like if you were trying to figure out, like, right, remember the formula was like b squared over 4 times a, to add to this thing? Well, in this case, b squared, so if you're wondering how they get the addition of just b squared, we have to consider, well, what exactly is b equal to, right? And in this case, b is equal to 4ab, right? That's the thing that's next to the x, right? It's 4abx. So if I take this squared and then divide it by 4 times, well, how much is a, right? A, in this sense, is 4a squared. You're going to get that this becomes 16a squared b squared over 16a squared. And this is going to simplify so that you're only adding basically b squared to both sides. Right? This simplifies to just be b squared. So they completed the square actually, and this is how they've begun to derive the quadratic formula. And then that makes this part the perfect square trinomial. And it's going to factor, right? So what's the square root of 4a squared? it's going to factor into 2ax, and then that's going to factor of b, square root of b squared is going to be b, and then in the middle is a plus. So from here, right, the inverse of stuff squared is square root of stuff. So they basically take the square root of both sides. So you get plus or minus the square root of b squared minus 4ac is equal to 2ax plus b. And right, then we have to subtract b from both sides. And you can kind of see the quadratic formula starting to take shape. And then the last thing we have to do is divide by 2a. So you get a negative b plus or minus b squared minus 4ac all divided by 2a. And I don't know if seeing how they derive the quadratic formula helps you remember it, but they did actually get there by completing the square. So for what it's worth, that's how the quadratic formula was determined to work and how they got it. So let's see some stuff with some real examples, and that should help some more. So here we go. If we're looking at this thing, right here is our ax squared. This is our bx, and that is our c. So a is going to be equal to 1, b is equal to a negative 2, and c is equal to 2. So we're going to try to determine, just using a portion of the quadratic formula. This portion is called the discriminant, and we can use the discriminant to determine the number of real solutions. And essentially all that means is, if you had a graph that looks like this, this would have 2 real solutions. If you had a graph that looks like this, imagine the vertex, right, only hits the x-axis at one point. That's one real solution. And then if you had a graph that looks like that, you see how the graph actually never hits an x-axis? That's called 0 real solutions. And all that means is the roots or the zeros of this equation would have I in them. So we plug in the numbers to the formula, right? It's going to be negative 2 squared minus 4 times a times c, and you're going to get essentially 4 minus, I believe, 8, which is going to be equal to a negative 4. So the way the discriminant works is basically if this thing, b squared minus 4ac, which is part of the quadratic formula, is less than 0, the equation has no real solutions. And, it's going to be a graph that probably looks something like that. It never hits the x-axis. Now, in these examples, right, this is great practice for eventually doing the quadratic formula, right? A is equal to 1, B is equal to 4, and C is equal to 1. And we're only finding the discriminant right now, which is b squared minus 4 times a times c. Well, b in this case is 4, so you're going to have 4 squared minus 4, a is 1, c is 1. So this is in essence 16 minus 4, which is 12, which when the discriminant is positive, it's a positive discriminant. That means 2 real solutions. And let's try another one. Right, there's part number 3. Here, A is 2, B is a negative 6, and C is 15. Let's plug it into our formula for B squared minus 4 times AC. Going to have basically negative 6 squared minus 4. A is 2, C is 15. So this is 36 minus, it looks like, 2 times 15 is 30, and 4 times 30 is 120. So this is definitely going to be a negative number, right? It's not necessarily important what the number is, although we can tell you what the number is, right? It winds up being, what, a negative 84. But because it's negative, that means there are no real solutions to this. As in, the solutions will be imaginary / complex, right? They're going to have I in them. That's what it means to not have a real solution. Is there a solution? Yes. But the solution is going to be a complex number, and we're going to dive in greater depth into that in Chapter 11. A, B, C. A is 1, B is 6, C is 9. Same formula, B squared minus 4 times A times C. So you're going to get, well, what is B squared? That's basically 6 squared. And fortunately, my 6's and B's look the same, right? It's B squared minus 4AC, the formula for the discriminant. So you have 36 minus 36 equals 0. When this happens, there is one real solution. So here we go. Now let's try to solve a problem using the quadratic formula. And we have to write it in standard form. Standard form is ax squared plus bx plus c equals 0. So we're going to do an activity tomorrow that's going to ask us the first question if this equation is written in standard form. And this one is not, right? You've got this 2x here. It needs to be over there. So we are going to have to subtract 2x from both sides. And once we do that, now it'll be in standard form. And essentially then we can proceed. A will be 1, B is a negative 2, and C is a negative 4. So now we're going to plug in all this stuff to the quadratic formula, which is, this thing right here. It's a poster on the wall. It's a template on an activity we're going to do tomorrow. And now I just, I kind of plug in all my stuff. My B goes there. Here again goes my B. 4 times A is 1. C is a negative 4. And then A again is 1. So now I try to simplify and clean up, right? And I'm just going to move some of this work out here so you can see, just this part is, what is negative 2 squared? That's going to be 4. And it's going to be 4 minus 4 times 1 times a minus 4. So this is essentially 4 plus 16, or the square root of basically 20. And you're like, well, how is it plus 16? We got the minus 4 here and the minus 4 here. A minus 4 times a positive 1 times a minus 4 makes a positive 16. So this is definitely the square root of 20. So square root of 20 there. And the opposite, right, here's a minus. A minus 2 makes a positive 2, which is right there. And then, of course, this square root of 20 is the same as the square root of 4 times the square root of 5. So that's going to simplify to 2 root 2. And then what is 2 times 1? Simply 2. And you're going to get 2 plus or minus 2 times the square root of 2 divided by 2. If I divide everything by 2, this simplifies to that. And then, of course, we have to figure out, well, x is either 1 plus the square root of 2. Oh, and I messed it up. It's not square root of 2. Let me undo some stuff. It's actually 2 times the square root of 5. So this is 1 plus the square root of 5, or 1 minus the square root of 5. And you're going to get about 3.236, or about negative 1.236. So let's see. The exact solutions are, right, 1 plus the square root of 5, 1 minus the square root of 5. And the approximate solutions are 3.236 and negative 1.236. And if I had x squared minus 2x minus 4 using the graphing calculator, we're gonna type this now into Desmos, and we are going to see for ourselves if our answer is in fact this, right? We should get a graph on Desmos that looks something like this. Definitely 2 real solutions, and our zeros should be at these points. So let's confirm that the graph does confirm the solutions. And so from here, I'm going to go to Desmos and show you that it does.